Hi, I'm Tobias Platzhalter from the Scalable Software Systems Research Group at TU Berlin, and I'm happy to present some of the work we did on evaluating unikernels as an edge fast runtime environment. When you think fast runtimes, you probably mostly think of containers, such as run C and Linux. In containers, you have process isolation. So you run your process, it's isolated, system calls are intercepted. With seccomp, there's isolation with C groups and namespaces. But that's efficient, but not very secure. That's why there's secure container runtimes such as gvisor, developed by Google, which add more complexity on top through system call trapping, through custom file system abstractions to make everything a bit more secure at the cost of a bit of performance. And you probably also know about micro VMs such as Firecracker used by AWS and Lambda, where you have a stripped down virtual machine environment. So you have a higher level of isolation through the traditional KVM abstractions, where your functional handlers can run in a proper virtual machine for the highest level of isolation you can get. But there's a different kind of isolation mechanism as well, called unikernels. In unikernels, your applications are executed directly on top of a hypervisor without an operating system between it. Instead, you have operating system primitives and hardware drivers, file systems directly embedded into your binary. And that runs on a hypervisor without the need for additional layers between that. That gives you a lean image, fast boot times, VM levels of isolation, and a small attack surface, which is great for security. There's different kinds of unikernels. The POSIX compatible unikernels that let you run a full Linux-like application. Nanos, SV, and Unicraft come to mind. And there's also language-based unikernels, such as Clive for Go, Runtime.js for JavaScript, and Hermit for Rust. We are focusing on the first one, the POSIX compatible unikernels, because we want to run untrusted Linux workloads, and we can't expect in a serverless environment that our developers and users compile the application for our platform specifically and use the kind of dependencies and languages that we support. We want to have as broad environment as possible for functions to execute. We did our evaluation using a lightweight fast sandbox that we implemented running on a single node. That's where the edge comes in. We didn't do this on a data center. We focused on a small kind of edge system, single processor. We used Go and Node.js micro benchmarks, and we looked for call start times, memory footprint, idle reset usage, I/O performance, and the like. And we compared OSV and Nanos as unikernels, gvisor as a secure container runtime, Linux and Firecracker, and Docker as a baseline for how much performance we can get when we sacrifice kind of levels of security. Our code is open source. It's available on GitHub. The link is here. So if you want to rerun those experiments and check it out, you can. Our results showed that unikernels are promising. We saw great cold start times, okay memory footprints, kind of in line with the other solutions that we evaluated. But we did find that the current state of unikernels are not really mature enough to use as a proper production SaaS environment. There were still performance bugs in both Nanos and USV in different areas. And we also found that run C is very hard to beat in terms of performance. But of course it's considered insecure, so that's no surprise that the trade-off here is a bit different. And we found that gvisor has terrible performance, which was not surprising. That result has been shown previously, but even compared to Firecracker and Linux, which is a bit weird because you expect it to be a bit quicker than running a virtual machine. The full results are in our paper. The link is here, so if you want to check it out on archive, it's currently under review and will be published soon. Thank you.